In this video, I'll introduce you to the mapping control in NetAdvantage for data visualization and how you can use it to display shapefile bound data. NetAdvantage for data visualization is available for both WPF and Silverlight, and actually it's the exact same API, developer, and user experience. So all the code and all the experience you will see in this video applies to both Silverlight and WPF. So let's start by looking at a sample project I've built here. So what we're looking at here is the design view of a window which contains the XamMap control. And this is the application which contains a single window with a map control which is bound to region data for the United States of America. This geographical data comes in the form of a shapefile, which is also accompanied by a DBF file, which stores a number of statistics about the different regions we see on screen. In this case, we've colored the different regions on the map here using the population of each state. So the population is represented by colors as shown in this color scale down here. We also have specified a tooltip which allows us to see a value which shows us the population for each and every state as we hover over it with the mouse pointer. So let's take a look at how this example is built. Okay, so we have one window which has the XamMap control in it. You can easily duplicate that by dragging and dropping a XamMap control from the toolbox into the visible area of your window. I've already done that. And now we're going to take a look at the XAML code, which will show us how this map is set up to show the data we just looked at. So basically our window contains a map control which specifies its layers as follows. In this case, we have just a single layer. We give it a name, states layer, and we set a fill mode to choropleth, indicating that we'll use a value to shade the different regions according to the values of this dimension, which is illustrated in the example we saw with the different colors representing the population sizes of the different states. So setting a number of different properties here, shadow fill, stroke thickness, and so on, for this specific layer, the most important bit that you need to take care of is how do you provide input in the form of geographical data for this map layer. In this case, this geographical data comes in the form of a shapefile. So you need to specify a shapefile reader in the map layer reader property, which allows you to retrieve data from a shapefile control and to display it in the map. In this case, this data will come from a file called USA_ST, which can be found in the shapefiles folder. So something to have in mind here is that the URI refers to the output directory of your application. So you need to make sure that you have a shapefiles folder in your project, and also that the files inside have copy to output directory set to copy always and build actions sent to content to make sure that these files will be copied to the output folder. An important property is the data mapping property, which allows you to map values in the DBF file, which is a companion to the shapefile, which may contain many different values about the regions that are represented in the shapefile. So using the data mapping property, you're able to create mappings between attributes in the DBF file, such as state name, state abbreviation, and population 1997, to properties which can be used by the map itself. So the caption property is mapped to the value that's displayed within the region itself. So in this case, we're directly binding the state abbreviation value for a region to the caption property of the map for this layer. So this tells the map to display in each and every region the value of the state abbreviation dimension for this particular region. In the same way, the population value in 1997 is associated with the value property for each and every region. So this allows us to construct a tooltip which directly references these properties for each and every region. So in this case, the tooltip will produce the name of the state followed by value, the value of the population. So this allows you to create very easily a visualization of your geographical data while also allowing you to tie into it different values representing the name of that region and also any value which is associated with it. And you can represent that in this case with a tooltip, and also once you set the fill mode to choropleth, the map generates each and every region with a color to represent that region's value in relation to all the other values in all the other regions. So specifying the colors for those is quite easy. You just need to set the brushes collection here with the different colors to be used. Also, you can specify the scale type to be used. In this case, we're using a linear scale since we don't have a great range in the values to be displayed. However, if you have a significantly greater range, you can always use the logarithmic scale. In this case, the linear scale will do just fine. We've also added to this map 3 controls which the user can use to navigate the map, for example, and to get a general outlook of it. So the map navigation pane basically consists of zooming controls and panning controls. The map thumbnail pane displays a small thumbnail representing the entire area of the map in a scaled down view, and the color swatch pane basically displays the value scale of how the different colors are mapped to the range of values represented in the map. So running the application again, you can get an idea of how you can use the XamMap control to visualize your geographical data and to display any values relevant to the regions within it in a user-friendly way.
Infragistics. On the web at infragistics.com.